So today we are going to discuss the topic of shortest distance between two lines. So the first thing what we gonna do is the shortest distance between two intersecting lines. So when we have the first one is two intersecting lines. Two intersecting lines. So what is the shortest distance between two intersecting lines? So that is given by, suppose we have a line in here and we have another line in here. This is line L1 and this is our line L2. So if somebody asks you what is the shortest distance between them, what you will say? The shortest distance between them is 0. Okay. So the shortest distance between two intersecting lines is, so shortest distance is equal to 0 for two intersecting lines. Clear? Now we move on to our next point. What is the shortest distance between two parallel lines? So when two lines are parallel, what is the shortest distance between them? So for two parallel lines, what do we see? We have line L1, we have line L2. Okay. Now if these two lines are parallel, the shortest distance will be what? I will take a point in here in line L1 and a point L2 in here. Okay. Now we have to check that the line segment joining the 2 points L1 and L2 must be perpendicular with both the lines. Okay, so the shortest distance between two parallel lines is the perpendicular distance between the two lines. Am I clear? Because if you draw this one, these are not the shortest distance. The shortest distance must be the perpendicular distance. So what is that? Shortest distance is equal to the perpendicular distance, or you can say perpendicular line segment joining the 2 points on the line. So I am just writing here perpendicular distance between the lines. Understood? Now we have a third set of line. The third set of line, suppose we have a line which is now in 3D we have a line which is neither intersecting, which is neither parallel. Then what happens? Can you think of any line? So look at here, I will just draw a 3D diagram in here. So now we have a cuboid like this. Okay, so it's like a 3D diagram. So think of it as a 3D. Clear? So let us name this one as A, B, C, D, E, F, G, H. Clear? Now in this box, draw two lines. Suppose I take a line through AG. I am taking a line through AG. So line goes like this, AG, right? Understood? Now think of another line. Just concentrate in here. Think of another line. Achha. Let's take another line going from H to D. Look, A to G is what? It's going through the ceiling. And H to D is what? It's going through inside the box. Understood? Now will they ever join? They will never join. Okay, so this one and this one, it's going like this, downhill it's going, and this one is in the ceiling. You have to visualize this one. Now if we have two such line, they will never intersect. Okay, and the another point is they are two non-parallel lines, right? So when we have such kind of lines, then those lines are known as skew lines. Okay, so skew lines are what? Lines which are neither parallel nor. So skew lines are what? Lines which are neither parallel nor intersecting. Am I clear? And they are known as non-coplanar lines. They are non-coplanar because they does not lie in the same plane. Suppose if I say these two lines, they can lie in the same plane, right? XY plane, YZ plane, like that. Now these two lines, they can never lie on the same plane. Okay, so skew lines are known as non-coplanar lines. Now if somebody asks you that how to find the shortest distance between the skew lines. So the shortest distance between skew lines is that, suppose this diagram is complicated, so let's draw a rough like this. Suppose we have a line like this and we have a line like this. Think of in your mind, acha, I will draw like this so that they don't intersect. Think of it as, so this is line L1, this is line L2. Now you would be asking that what is the shortest distance between these two lines. Now look at here, they are not meeting. Okay, so what is the shortest distance between these two lines? The question might come in your head. The shortest distance is, it will be a line segment joining the 2 points of the line 1 and line 2, which are perpendicular with both the line 1 and line L2. Am I clear? So how to find the shortest distance between two skew lines? So it will be a line joining the points in line L1 and line L2, and that line segment which is formed by those points will be perpendicular to both line L1 and L2. Clear? So that's the discussion of shortest distance between two lines. So let us start with finding the distance between two skew lines. Okay, so let us start with the discussion. So we will write here distance between two skew lines. Okay, so let us find the distance. So suppose we have a line L1 which goes like this, and we have a line L2. They will never intersect. Line L2 which goes on like this. Okay, now what I will do, we have already learned what is the equation of a line, right? So what was the vector equation? Suppose line L1, the equation of line L1 is given by R vector is equal to A1 vector plus lambda B vector. Now you would be asking, what is A1 vector? A1 vector is the position vector of a point. Suppose I take a point S in the line L1. Am I clear? So what is S? What is A1 vector? A1 vector is the position vector of the point S on the line L1. Now, and what is B vector? B vector is a parallel vector. So line L1 is parallel to some vector, right? So that is B vector. Okay. Now line L2. So the equation of line L2 is given by R vector is equal to A2. So here let us write this one as A1 vector. A2 vector plus mu. This one will be B1 vector. This one will be B2 vector. Why it is B1? Why B2? Because they are not parallel at all. If they were parallel, then these two would have been equal. Clear? Now A2 vector is what? Let's write here a point T whose position vector is A2 vector. Okay. So let us join these 2 points ST. Now this is what? A general line segment. We are picking any point on line L1 and we are picking any point on line L2, and we are drawing a line with those 2 points. We'll get a general line segment, that is ST. Am I clear? Understood? Now what is B2 vector? B2 vector is a parallel vector of line L2. Okay, so these are the facts which are given, and what we need to find, we need to find the distance between them. And I already told you the distance between two skew lines is the line segment which is perpendicular to both line L1 and line L2. Clear? So this has to be the perpendicular line. So let us give it its name as PQ. Okay, so PQ. So we actually need to find what? We need to find the magnitude of PQ vector. Okay, so this is the thing which we need to find. Understood? Now can you tell me what is the what is the vector form of ST? What is the vector form of ST? ST vector, what is that? ST vector is what? Terminal minus initial. So terminal vector is what? A2 vector minus A1 vector. Understood? Now Now look at this one. This PQ vector is actually what? This PQ vector is nothing but the projection of this ST on a line which is perpendicular to both line L1 and L2. So what is that? What can I write? PQ is the projection of ST vector along the direction of the line of shortest distance. Yes or no? PQ, the distance PQ which you are finding, the distance is what? Is actually the projection of ST vector along the direction of a line of shortest distance, the projection of this one on this line, right? Now, I already told you what is projection of A vector, along B vector. What was the formula? It was what? A dot B vector divided by B. It is basically A vector dot B cap. Yes or no? That was how we used to find the projection of A vector along B vector, right? But one thing, do we know the direction of this one? We are saying that we have to find the projection of ST on this direction, on the direction of the shortest line, right? But do we know the direction of this one? I just need the direction. Look at here. I need the direction only along which we have to find. So do we know the direction of this one? No. So can we find the direction of PQ vector? So we have to find what? The direction of PQ vector. We have to find the direction of the shortest distance, and direction of PQ vector is just PQ cap, right? Now can you tell me what is the direction of PQ vector? Listen very carefully. What is the direction of a vector which is perpendicular to two vectors? How to find direction of a vector which is perpendicular to two vectors? You see, A vector and B vector. What is the way to find a vector which is perpendicular to both A vector and B vector at the same time? Cross product. Yes or no? We have done this one. Cross product is the way how we find the vector which is perpendicular to both two vectors. So here we see line L1 and line L2. What is the parallel vector across line L1? It is B1 vector. What is the parallel vector along line L2? That is B2 vector. So we are finding the direction of PQ which is perpendicular to both B1 and B2. Understood? Perpendicular to L1 means what? Perpendicular to B2, and perpendicular to L2 means what? Perpendicular to L1 means perpendicular to B1, and perpendicular to L2 means perpendicular to B2. Clear? So what will be the direction vector of PQ? So it will nothing but the cross product of B1 and B2. And listen carefully, it's a unit vector. So what do? We divide by B1 cross B2, the magnitude of B1 cross B2. Understood? So this is the unit vector which gives the direction of the shortest distance. Am I clear? Now what we have asked you to find? We have to find the projection of ST along this one, right? So what we will write? Projection, therefore projection of ST vector along PQ cap, or you can write along PQ vector is equal to what? We have learned this one before. It is ST vector, we have done this one in here, PQ vector divided by the magnitude of PQ. Yes or no? Right? Now we already know PQ vector divided by PQ is actually what? This thing. And so it will be ST dot B1 cross B2 divided by B1 cross B2. The magnitude, right? And we already know what is ST vector. ST is what? A2 minus A1. So the formula will go like A2 minus A1 vector bracket dot B1 cross B2 vector divided by B1 cross B2 vector. Understood? So that's the way how you find the shortest distance between two skew lines. Am I clear? Okay. In your book the derivation is too big. I think this is the best way of doing this one. Okay, this is how you can easily remember this one. Okay, clear? Now let's derive the Cartesian form of that. The Cartesian form of that thing. So Cartesian form of that shortest line we have to find. So Cartesian form. So in Cartesian form, what is the equation of line L1 will be? It will be x minus x1 by a1 is equal to y minus y1 by b1 is equal to z minus z1 by c1, right? In the same way, L2 will be what? X minus x2 by a2 is equal to y minus y2 by b2 is equal to z minus z2 by c2, right? Where x1, y1, z1 is that position vector, that a1 vector, and x2, y2, z2 is that a2 vector, and a1, b1, c1 are what? The parallel vectors, and a2, b2, c2 are the parallel vectors b2. Am I clear? Now, what was the formula? What was the shortest distance formula? The shortest distance formula was, one thing, we haven't written one. So, let's write. So, the shortest distance is equal to, what was that? It was B1 cross B2 dot A2 vector minus A1 vector divided by B1 cross B2. This was it, right? So first thing I have to find what is B1 cross B2. So B1 cross B2 will be given by what? I am deriving that Cartesian form. So B1 cross B2 will be what? It will be I, J, K, and B1 it's A1, B1, C1, A2, B2, C2, right? Now can you tell me what will be the magnitude of this one? B1 cross B2, we have already done this one. So magnitude of this one will be equal to what? So I hope you guys will find it out, this one. So let's just directly write that thing. So that thing will be equal to root over of B1 C2 minus B2 C1 square plus C1 A2 minus C2 A1 whole square plus A1 B2 minus A2 B1 whole square. This is B1 cross B2. Okay, fine, I will teach you this one after finishing this one. So this two we got. Now we have to get A2 minus A1. So what is A2 vector minus A1? Now what are the coefficients, components of A2 vector? A2 vector is what? x2, y2, z2, right? So let's write down. So it will be x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap, right? Understood? Acha, fine, let's derive this one. If you are having problem with this one, let's derive. So first thing, b1 cross b2 vector, I can write this one. Let's expand this one. So I cap, this one will be this one b1 c2 minus b2 c1. Okay, then minus j cap, then it will be a1 c2 minus a2 c1, then plus k cap, it will be a1 b2 minus a2 b1. This is what we have, right? And what is the magnitude of this one? It is root over of this square plus this square plus this square. I don't care about the minus because minus whole square becomes plus. Okay, that's how we got the magnitude of that thing, right? Now let's put the values in here. Let's put the values, all those values in here and see what you get. So shortest distance, therefore shortest distance is equal to, now you see here, I will do this one directly. Now if I do the dot product of this thing, I'm not taking about this one, I'm taking about this one. If I do dot product of this one and this one, if I do the dot product of this one and this one, what do I get? I already explained this one before. So here what I get is I dot I, it is x2 minus x1. Then j dot j, it is y2 minus y1, then k dot k becomes z2 minus z1. Okay, now the rest will remain same. That will be a1, that will be b1, that is c1, that is a2, b2, c2. Now whole divided by, it will be root over of this thing, that is b1 c2 minus b2 c1 whole square plus c1 a2 minus c2 a1 whole square plus a1 b2 minus a2 b1 whole square. Okay, so that's how we find the Cartesian form.